Yesterday, we looked at a couple algebraic techniques to evaluate a limit. We looked at how we can use direct substitution and also the dividing technique. Today, we're going to look at another scenario where when we try to use direct substitution, we end up with that indeterminate form. And so we're going to use a new technique called the rationalizing technique. This is going to come in handy when you're looking at all of these limits that I have here. You can see that they all have a square root in them. And when I try to go and do direct substitution into these problems, if I try to replace the x with 0, in this fraction right here, I'm going to get 0. And then in the denominator, I'm going to get the square root of 9, which is 3, minus 3, which is 0. Once again, I'm left with that indeterminate form. And before, that was the symbol that we could do some type of algebra, and we looked at factoring techniques yesterday. But in these problems, we can't factor these expressions. So what we're going to do instead is rationalize. You may remember from algebra 2 that when you rationalize, what you're doing is multiplying by a conjugate. So what we're going to do is we're going to look at the part of our fraction that has the radical, and we're going to multiply the numerator and denominator of this fraction by the conjugate of the radical expression. So if I have the square root of x plus 9 minus 3, I'm going to multiply by the conjugate, which would be the square root of x plus 9 plus 3. And again, we do that to the numerator and the denominator. Now, a quick tip is that when you are going to simplify in the next step, you only want to multiply the part of the fraction that contains those conjugates. So down in my denominator, I'm going to multiply these two out, but on the numerator, I'm not going to multiply that through. So I'm just going to leave that written as a product. So I'm going to leave my numerator as x times that quantity of the square root of x plus 9 plus 3. And then in my denominator, I'm actually going to multiply. Now, the reason why we multiply by the conjugate is because we're going to be able to multiply the first terms together. And when you multiply a square root by itself, it just becomes x plus 9. The square root sign cancels out. Using the conjugate, your outer and your inner terms will cancel. You'll get that negative 3 times the square root of x plus 9, and you'll get that positive 3 times the square root of x plus 9. So those terms will cancel, and then we can multiply our last terms. So negative 3 times positive 3 is negative 9. So I left my numerator as a product, and I took the time to FOIL out my denominator. And because I'm using a conjugate, really I ended up just multiplying my first terms and my last terms. And that gave me that expression down there. If I go ahead and simplify this now, in my denominator, I'm left with just x. So my numerator is that big mess that we created using that conjugate. But down in the denominator, I have x. The reason why I didn't bother multiplying this through is because now these have a common factor of x that can be simplified or now divided out. And then lastly, I can go ahead and replace x with 0 in the remaining piece of that function there. So the square root of 0 plus 9 would be the square root of 9, which is 3, plus 3. My final answer for this would be 6. Now notice in this problem, I ended up with the indeterminate form and my square root was in the denominator. It does not matter where your square root ends up. So all that's going to matter is that you're left with an indeterminate form, 0 over 0, and the original function had a square root in it, and that's where we're going to use that conjugate technique. So in this example, notice the square root is up top. But that's not going to be any different from what I would normally do. Again, I always start by trying direct substitution and hoping it works. So my limit as x approaches 0, I'm going to replace in here, and I'm going to get the square root of 16, which is 4, minus 4, and I get 0. And then because my denominator was just x and my limit as x approaches 0, that would be 0. So once again, I get that indeterminate form, which tells me there should be some algebraic technique that I can use to clean this up. And for this problem, again, it's going to be rationalizing because of the square root. So I'm going to go ahead and copy over my original limit. Oops, I made that square root symbol too long. And then I'm going to go ahead and multiply the conjugate. But this time I'm going to use the conjugate of the numerator because that's where my square root is. So I'm going to multiply the numerator by the square root of the quantity of x plus 16 plus 4. And again, I have to also multiply my denominator by that same expression. This time, I'm going to take the time to multiply or FOIL through the numerators, but I'm going to leave this time the denominator as a product. Again, you only want to multiply out your conjugates. You do not want to multiply the expression that's not a conjugate. So I just copied the denominator as a product, x times that whole quantity there. And then now I'm going to FOIL the numerator. Now again, because these are a difference of two squares, all I really have to do is multiply the first together. So the square root of x plus 16 times the square root of x plus 16 is just x plus 16. Negative 4 times positive 4 is negative 16. I can go ahead, clean up that limit by simplifying the numerator. X plus 16 minus 16 is just x. And then I'm going to keep that denominator as that product. Once again now, I can go ahead and divide out the x's. But because I'm dividing out the x that was the only term left in my numerator, remember we're going to put a 1 up there to hold the numerator's place. Because anything divided by itself is equal to 1. So now that I've cleaned it all up, I'm going to go ahead and do direct substitution to my new fraction here. So as x approaches 0, I'm going to replace this x with 0. And I'm going to be left with 1 in my numerator. And then I'm going to have 0 plus 16 under that radical. So the square root of 16 is 4, and 4 plus 4 is 8. So my limit as x approaches 0 for this fraction would equal 1/8. Now, I don't want you to always think that this is only going to happen when you have limits as x approaches 0. It can really happen anytime you have that indeterminate form of 0 over 0 and a radical expression. So we're going to look at one last example that's a little bit more complicated than those first two. And then you're going to go ahead and try this dividing out technique using rationalizing to help you solve these problems. So in this last example, I want to find the limit as x approaches 2. So once again, I always try direct substitution and hope that I get a real number. But when I replace 2 in this fraction right here, and I get the square root of 18 minus 2, which is the square root of 16, which is 4, in my numerator, I'm going to get 4 minus 4, which is 0. And in my denominator, 2 minus 2 is also 0. So once again, I was left with that indeterminate form. So that means I want to use some algebraic technique. And because I see the square root, that's my symbol to rationalize. So I'm going to copy the limit over the way it originally was. And then in my fraction, I'm going to multiply the numerator and denominator by the conjugate. And again, you're looking for the conjugate of the expression with the radical. So in this case, that 4 minus that square root of the quantity of 18 minus x. So the conjugate is just going to be 4 plus that square root. And again, we're going to do the numerator and denominator using that same conjugate. Again, as I go to multiply, I only want to multiply the part of the fraction that contains the conjugate. So as I'm trying to simplify this expression, I'm going to FOIL out the numerator, but I'm going to leave my denominator as that product. So I'm not going to multiply this through. I'm going to leave it as that quantity of x minus 2, and then times that quantity of 4 plus the square root of 18 minus x. I only want to multiply through or FOIL the conjugate expression. So again, I'm going to do 4 times 4, multiplying my first terms for this difference of two squares to get 16. Then I'm going to put minus, and I'm going to multiply these two together. Now I have to be careful with this problem because as I'm taking the square root times that square root, I'm getting the negative quantity of 18 minus x. So I want to make sure I put that in parentheses there. Now I'm going to distribute through that negative sign to keep cleaning up my numerator, because unlike the last example, I can't just combine here and get x and be done with it. So I have to actually distribute to clear those parentheses. So we're going to get 16 minus 18 plus x. And again, I'm leaving that denominator alone. And then, as I clean up the numerator, I have a positive x, and then 16 minus 18 is negative 2. So now my numerator became a factor of x minus 2, which notice was the original factor that we had starting at the problem. And we still have that conjugate down there. So now once again, I've used my algebraic techniques. I'm going to go ahead and I'm going to divide out the x minus 2 factors. Because this was in the numerator, I'm going to put the 1 up there. And now I'm going to go ahead and try direct substitution on that remaining expression there. So my numerator is going to be 1. And then in my denominator, I have 4 plus the square root of 18 minus 2, or 4 plus the square root of 16. So 4 plus 4 would give me 8. So my final answer would be 1/8. So anytime you're using direct substitution and you get 0 over 0, you get that indeterminate form, there's some type of algebra that can be done. And sometimes that algebra is just using factoring techniques and dividing out the problem like we saw yesterday. But sometimes we might have to use a conjugate, and that's going to occur anytime our examples have square roots in them. If you have any questions, please reach out.